All right, pre-calculus. So here are going to be the next 3 videos or series of videos to help with any sticking points that you might be forgetting about inverse functions. So we finished with compositions of functions, and I talked about that there might be a property that's linked when we do certain compositions that we get the same answer regardless of how you put the functions. Doesn't matter the order in which you do the composition, that you would get the same result. So we're going to talk about that today with inverse functions. So before we dive into that, we're going to go ahead and go to our whiteboard, and this video is going to focus on the notation. So I want to be clear about how do we notate an inverse function. So when we have a function f of x, when we want to talk about its inverse, and let's actually take a moment to talk about what does this term inverse mean. It means we are doing the opposite operation. Okay, the inverse. So if we were adding, we're going to subtract. If we're multiplying, we're going to divide. If we're raising it to a power, we're going to take a root, or we're going to do a radical of that. So we're doing the inverse. Now, inverse does not mean that we are going to do a reciprocal. So the reason I bring that up is the notation for inverse. So inverse of f of x is notated like this. So we see this f to the -1 of x. This is not a power. This is a notation to let me know I'm doing the inverse of f, not the reciprocal. So we are not, this does not mean that we're going to say 1 over f of x. That is not the inverse. That's not the opposite operation. That's just a reciprocal of what we're looking at. So when we do numbers, yeah, this power means we essentially flip over the fraction. But when we talk about functions, it does not do the same thing. It does not mean for us to do that. All right, so now let's go ahead and talk about what does it mean further about what it is that an inverse does. So an inverse undoes what the function did. So if we have some function f, so I plug in x and it turns it into y. So I would create all these xy coordinates. If we have the inverse function to f, it would undo everything that f did. So if I started by plugging in that output, so this is input, so this side here is input, and this side is output. So if we were to plug in the output from the original function f, I would get that original input back. So it's undoing everything. Just like adding and subtracting. Oh, if I add 5, how do I undo that? Oh, I subtract 5. That is an inverse. Oh, I multiplied by 3. Okay, so I'm going to divide by 3. That undoes that operation. If I raise something to the second power, so like, 5 squared. If I'm going to undo that, what do? Oh, I take the square root of 5 squared, which is, this would be 25. So it would undo that. So this and this are inverse functions of one another, inverse operations of one another. So when we talk about finding inverse functions, so I'm going to start to talk about it here and then carry it on into the next section. What we want to do is we want to find functions that are doing the opposite of what we see. So this will become more and more complex the more operations we string together. If it's a single operation, it's pretty straightforward. We just undo it. But what happens when we start to put a bunch of operations together? So for example, let's say we have the following. So 2x plus 3. So I see that I am multiplying by 2 and I'm adding 3. Okay, so I could initially say, well, the inverse is just going to be us undoing all of that. So instead of multiplying by 2, I'll just divide by 2. And instead of adding 3, I'll subtract 3. So this must be the inverse, right? Wrong. This is not the inverse. in order to do the inverse, not only do we have to undo the steps that we did, but we also have to pay attention in what order those steps were originally done. So it's not just simply, oh, I see multiplication, I'm going to do division. I see addition, I'm going to do subtraction. I'm not just simply reading across and undoing all the operations. I have to pay attention to the order in which operations were done. So up here, this 2x plus 3, what did I do first? So if I plug in a number, oh, I would have multiplied by 2 first, and then I would have added 3. So if I'm going to undo that, so remember, this was first and this was second. So if I'm going to undo what this function did, I have to undo those steps in the opposite order. Kind of like rewinding film. Like if you go backwards in time, it just doesn't go to the beginning and everything running backwards. You start from the ending and you work your way backwards. So the same thing here. So my inverse function would be what? Oh, I have to undo this 3 first. So that means I'm going to take my input and subtract 3. Then I'm going to take what I have and divide by 2. So this is the inverse versus what I had before. This is what I had said originally. This is not the same as this. So this is the wrong function. This is the right function. Okay. Now your book details a way of doing this a little bit easier, and that is, and I'm going to show you here, is to, instead of saying f of x, I'm going to temporarily say y equals 2x plus 3. And the book says, okay, switch x and y first, and then solve for y. Now, why is it that this method works? Because when you do it this way, you are, without explicitly writing it out, you are undoing the function in the opposite order. So that's why they give you this technique in the book. So if I were to continue following this throughout, so now, okay, I'm going to solve for y, so that means the x would move over, and then I would divide everything by 2. So now this is the inverse, which you see matches up with what we had originally done. So that's why that particular method works. All right, so, oops, just fix this here. All right, so in our next video, I'm going to continue to dive into this a little bit further. How do we find the inverse function? This is how to find it algebraically. How do we find it graphically? How can I be able to make a picture? Maybe I don't have the equation, or I don't necessarily know how to undo the function. Can I still be able to look at what the inverse is? And the answer is yeah. So we're going to look into that in our next video. So if you're still curious about it, please make sure to check it out. If this video you found to be helpful, please hit the like button at the bottom, subscribe to the channel, and I'll see you on the next one.